The goal of this tutorial is to introduce an absolute novice to some of the functionality of Python. As you may know, Python is a programming language that is often used in data science applications because of its simplicity and the community support. We will use Google Colab for our playground. You can load it by typing Google Colab into your search engine and clicking the top link like this. All right, this will require you to sign in with your Google account, and you will see a window like the following, where you can choose File, New Notebook, and that will open a new notebook where you can do the coding. And I have my notebook open and available, and you can either type in all of this information yourself and follow along, or you can just use my notebook, which is available via a link down below. If you would like to learn more about any of the discussed here topics, I have additional links available down below as well. In the first cell, you can see that we are assigning variables A and B numerical values, and then we perform a simple math operation, summation. Okay, so to execute this cell, we can press either this run button or type Shift Enter using the keyboard, and this will execute this code in the cell. And you can see that we get the output 7, which is the summation of 2 plus 5, right? In the next cell, we have multiplication, okay? 2 times 5 is 10. The following is the division, okay? A divided by B, which is 0.4. And the final cell, as an example, raises variable A to the power of B, okay? Which is 32. Right, so you can see that it's really, really easy to perform simple math operations in Python. And in the next topic, we'll learn about various data types that Python has. The variables in Python can have different data types, which are the classification of the data items, right? And so that's what we're gonna become familiar with in the following couple of cells. So if you're not sure what data type your variable is, you can always use a function type, all right? And so by executing this piece of code, we can actually check what is the data type of variable A. All right, and we can see that it's an int, an integer or a whole number, and that is indeed correct because over here we indicated that A is equal to 2, a whole number. Right, you can easily change data from one data type to another. For example, here in the next cell, we assign in to variable A a value 2.0, which has this decimal point. So let's see what kind of data type it is now. All right. So it is a float. All right. It's a more advanced data type because it can now, instead of whole numbers, we can have decimals. All right. Well, it's also easy to convert back to an integer by using a function int, right? And by executing the following code, we can indeed convert A to being, again, an integer. Finally, the other simplest data type is a complex number. And here we're assigning to C a complex number consisting of a real part and the imaginary part indicated by this variable J. Okay? So it is a complex data type. Other Python data types are a string, list, and tuple. And a string data type is what we use to deal with text or an array of Unicode characters. This data type is easily indicated by placing that array of Unicode characters between a single, a double, or a triple quote. All right, and so that's what we do in this first line of this cell, where we assign to a variable text the information, the text. I love data signs. So let's see what type of data data it is. So we execute this code and see that it's indeed a string. Okay? A list is a data type that is an ordered collection of data. For example, in this cell, what we're doing is we're creating a variable list of the list data type, okay, by using the square brackets. And this variable will have a collection of data of different data types. For example, a string age as the first element, and an integer 29 as the second element. All right, so let's execute this cell and see indeed what type of the data type it is, okay? And so that's what we have done. We printed the variable list, which is a collection, okay, of age, a string, and an int 29, and it's a list data type, all right, a special one. The good thing about lists is that, well, you can store data in those variables and you can access them because this is an ordered collection of data, all right? So in the next cell, we are printing out or displaying this first element, which has an index 0, all right, of this variable list. And you can see that it is an element of, age, which is a string, because this was the first element in the variable list. All right. And the second one is an integer 29. An interesting thing about lists is that we can actually change the contents. All right, so for example, let's change our element 1 to something else, and we can do it easily if we just type a new value here. All right, and let's see what kind of list is now. So let's use a function print our list, and instead of being age and 29, it's now age and 30. So this is a very special thing for lists. Tuple as the data type is very similar to a list in that it's an ordered collection of data. All right, so in this cell, we first assign to a variable tuple a data type tuple which has two elements, a string age and an int 29. All right, and then we can just print out, for example, a whole variable tuple and see what type of data type it is. Okay, and we see that it's, again, it's a tuple consisting of two elements, age, a string, and an int, integer 29. It's a data type tuple. Now, what's different between tuples and lists? The difference is that tuples are immutable. You cannot change the contents of this data type. For example, if I will try to change as before my first element, all right, from 29 to 30, we're going to see that this gives an error. Okay, the tuple object does not support item assignment, so we cannot change the tuple once it is created. So that's the difference. The boolean data type is used in logic operations. For example, in this cell, we perform an operation where we can, inquire about the content of variable A. Is it equal to 3 or not? All right, so if we run this cell, we see that it's false. Okay, A is not equal to 3. Why? Because, well, let's look above, and we assigned A to be 2, all right? So therefore, we got this, as false. Now let's see what type is this variable is, okay? And it is a boolean. Finally, let's talk about two last data types, namely a set and dictionary. Okay, and the set is similar to a list in a way that you can create them by a function like a set function, and it can hold different types of data. Okay, so for example, here we have a set of 2 elements. One is the string type, and the other one is the integer type. Okay, and we can check with the type function to make sure that this is indeed a new data type here. All right, so that's what we have. And the difference between sets and lists is that sets cannot be accessed, the data in sets cannot be accessed by referring to an index. For example, if I try to print my first element in a set, okay, if I do that, I get an error which says that the set object is not subscriptable, so that is the issue. However, you can still access elements in a set if you loop through the set items, for example, using a for loop. So this is one of the examples I wanted to show here. So if we run a for loop, then we can print each element, and we can see that indeed we have 2 of such elements in a data set called data type called set. Okay. And dictionaries are different from all other data types, which hold only a single value as an element. The dictionary holds a key value pair. Okay, so let's look at it here. In this line of code, we're defining a dictionary, okay, as a data type, and we define it using a curly, set of curly braces, all right? And then for the first element of this data type, right, of the dictionary, we actually have a key and a value pair. So one is the key, okay, and this is the pair. This is the value that this key refers to, all right? And you can have other elements, and those would be now separated by comma. So this is now a second pair of a key and a value, and this key refers to this value, all right? So this way the data is considered to be more optimized once it's stored in dictionaries. So we can run this cell, and you can see that indeed we have a separate data type, a dict or dictionary data type, and this is the contents of our dictionary named dict. Okay, so that's all about different data types that I wanted to tell you, and we'll continue with more advanced topics after this. Python has already a lot of functions that we can utilize for our purpose. For example, we already heard about the type function, which lets you determine the type of various variables you may be dealing with, and the print function, which just prints some messages for us. Okay, but the power of Python also is that you can create your own functions. All right, and this you can see, for example, here when we create our own function that we call the summation function. So we use a def statement to define this function, which will utilize two arguments, a and b, and this function will take and sum those a and b arguments, all right, those past values, and calculate this sum, right, and return it, right? So whenever you call a function, it will return you some information back, and so this sum is returned, right? So let's run this cell, okay, and see what happens now if I pass the two arguments 3 and 6 to the summation function, and the outcome of that will be stored in a variable c, and then we'll print this c out with the print function. Okay, so you can see that our function summation has calculated a sum of 3 and 6 and returned it as the variable c. Okay, so of course you can come up with many more functions. For example, we can create functions such as division. So we'll define it as division, and we also will use two arguments, a and b. Okay, and so return div equal a divided by b. Okay, I'll return it here. So I can call now my function. Let's call it now division, and we're going to have 4 divided by 5. Let's print it out. Let's print out d. Okay, so let's see what happens. I would have to run my top cell, and now if I run the bottom one, we're going to see that 4 divided by 5 is indeed 0.8. This way we can create a lot of many different functions, and in order for us not to get lost, okay, we can combine these functions within classes. So let's talk about classes in Python. Okay, and so in this example, for what we have, we create a special class math within which I'm going to have many different functions and methods pertaining to this class. So therefore, I have a class statement at the top, and then within this class, I'm creating a function division, okay, which will return the result of a division of two arguments a and b. Then I can also define a function summation within this class and return a sum of arguments a and b. Okay, so that's how you can create a class. And if we now run this cell, okay, we will let Python know that we have created this class, and I can then address the functions from within this class using the statement where we start with the name of the class, then dot, and then the function or method that pertains to that class. And we pass two arguments, 3 and 5, and we print out the result of this operation. Okay, and you can see now indeed we have achieved the summation of 3 and 5, and this way, for example, I can create a variable d, which will hold the result of division. You see, I selected my class math, put a dot at the end, so I can see now a function within this class called division, so I can call it, and I can pass arguments to this function, for example, 4 and 5, and I can then print out the result. So let's rerun this cell and see what we get. So we'll perform another operation, and we can see the result, 0.8. Right? So that's the idea of classes. The power of Python is that the users have created a lot of such different classes with many very different useful functions that we can utilize. Okay, and such classes, useful classes, could be imported as libraries. Okay, so one of such important libraries is the Numpy library. Okay, so we can make use of it in our calculations pertaining to data science. Okay, so we can use this library if we first import it. So we use a statement, import statement, where we say that we want to import this Numpy library as NP. And then once it's done, we can perform various operations, using those classes of functions, very useful functions. Okay, for example, in this statement here, we create an array using an array method from this Numpy class, Numpy library, and we create a 2D array where we define a first row of values and then a second row of values of this array, and we then print it out so we can actually see, okay, this array. All right, so we have created a 2D array, which is indicated by these square brackets here, with 2 columns and 3 rows, two rows and 3 columns. Okay, and then we can create another array. That's what we're doing here, and let me show that indeed this array functionality, this method is available in the Numpy library. So if I start typing array, it shows up here as in this list. Okay, so we create a second array, and we can perform operations now as such arrays very easily. So the power of such pre-made libraries is that we don't have to come up with the proper rules of multiplications or divisions on our own, and we can just use already created functions. All right? So in this line of code, what we're doing, we're just performing a multiplication of those elements of array, okay, one by the other, okay, and then we print out the result. And you can see that indeed the elements of this array 3 are obtained by multiplications of the elements of array 1 and 2. Okay, and now we can also perform vector multiplication, dot multiplication. Okay, for that, though, we would have to transpose our array 2, and we do this by using this transpose function, and then we perform the dot multiplication, so vector multiplication, and output the result. Okay, and the result of multiplication of such transposed array 2 and array 4 is now a 2 by 2 matrix. Right? So with Numpy library, we can do a lot of very useful operations pertaining to data science. Another very useful library that I would like to mention to you is the Matplotlib library. Okay, it allows you to plot very conveniently your data and display it. All right, so we import this Matplotlib pyplot library, okay, SPLT, and then we can select our data to plot. For example, as my X values, I'm going to select the first row of values from my array 1 vector. Then I'll print those values, and then as my Y values, I'm going to choose a second row of data from my array 1, and we'll display those values before we plot them. Okay, and then we can plot them in a moment. Okay. So we execute this content, and you can see that my X values are 1, 2, 3, and my Y values are 2, 4, 6. So twice the X values, right? And then I can make a very simple plot by using a plot function from the Matplotlib pyplot library, okay? And this is how we call it. We specify X and Y values, and we display the simple plot by using the show method, okay? So if I now execute this cell, you can see a simple plot, okay, where we have my Y values, my X values here. And you can have many different types of plots that you can specify. And here you, for example, can see how I can use a scatter type of plot to display my data. So then if I execute this cell, you can see the scatter plot of my 3 data points, okay, Y values and X values. Finally, let's talk about Pandas. Pandas is a library that provides a lot of data analysis friendly features, which make it one of the most popular data science tools. It builds up on Numpy, so most Numpy features hold true with Pandas. But in addition, Pandas allows very easy working with data, its manipulation, transformation, and visualization. So let me show a couple of examples of that. So in this line of code, what we're doing is we're importing the Pandas library as PD. Okay. So after that, we introduce one of the data structures that Pandas uses, Pandas series. Okay. A series is a one-dimensional array-like object. Okay, and it acts like an array, but supports many data types: integers, strings, floating point numbers, Python objects, and so on. And it indexes this data. So, for example, here we see we are creating an SER variable, which is a Pandas series. Okay, and we have our data there, this list, okay, with values which are integers, and we index this data. So index is like the header for a column with your data, okay? So this would be your header, and this would be your data, right? So let's run it and see what we get, okay? So we created series, and then we printed this variable SER, and we see that we have created, well, the data type there is integer, and we have our data and our indices here. All right. So we can, if you get a question like what indices are of your Pandas series, we can use an index function to display just the indices. Okay, so this would be now your indices. If you want to select the data with only a particular index, so you can use this, code line. Okay, and this would display just the data with the index Alex, and you can double check that this is indeed correct here. Now you can also check if there is any particular index in your series using this line of code, and it is true. So there is data with index Bob in our series, and we can see indeed, yes, here's Bob. And it's very easy to operate with data in your Pandas series. For example, just by this very short line of code, right, we can double the data values by 2 in our series, right? So we can double check that now all of our data are twice the values they were before. So that exemplifies the utility and ease with which you can use data in Pandas series. Okay. A more advanced data structure in Pandas is dataframe. So here you can see how we can create one from a dictionary of Pandas series. So in a way, dataframe is just a dictionary of those series, right? And so we have one series and then second one, and together they make a data frame. So let's see this. Okay, we created this data frame, and now we want to display it. Okay, so we see that now we have our indices, and we have also 2 sets of the data, 1 and 2, because 1 was from one series and 2 from the other. And if we didn't have the data in those particular series, but had it in the other series, then we would get this NaN values. All right, that is so because, for example, in the first series, we actually didn't have a data with index Alex. Therefore, we got NaN, but we had it in the second series, right? So that's how we get those NaN values. But not to fear, that just means we have combined 2 series together in one data frame. And so that's actually very powerful for data analysis, right? We can use similar functions to display just the indices, okay, or just the columns of data. Okay, so we'll get indexes of those columns, 1 and 2, and we can perform operations on those columns of data. For example, we can create a new column 3, which will be a result of multiplication of data in my column 1 and data in my column 2. Okay, so let's verify it. Right, so indeed we got our 3rd column of data, and whenever we had some values in column 1 and 2 for those indices, we get a product of those data. Okay. Now, if you want to get rid of those rows of data where we have NaN or absence of data values, you can use a drop NA function. So this way you kind of clean up your data frame. Okay, so let's verify it. And indeed, we are only left with those rows of data which do not have NaN. We can also quite easily delete whole columns of data. For example, here we delete column 2, and we're only left with 1 and 3. And finally, let me show how one can easily save the data to CSV file by using a toCSV function. All right, so this line of code saves our data frame to a CSV file with this file name. Okay, we can verify this by using that saved file to create a new data frame, df2, and displaying it. So if I now, for example, try to display df2 and rerun this line of code, I will get an error because we actually we haven't defined df2 yet. So we have no data in this data frame. But if I now create it from my file 1 CSV data, okay, then it actually exists. So this is verification for that. So you see, these are all easy examples that exemplify the power of using Pandas and different data structures within Pandas, such as series and data frame, to manipulate your data and use it for further data analysis. Okay.